Section 4.6, Special Products. In this section, we're going to continue our look at multiplying polynomials, but we're going to focus our attention on a couple special cases. Let's just start with a problem from the last section. It might look something like this. Now at this point, you should recognize that is a FOIL problem, because what have we said? You cannot distribute a power over a sum or difference, so this is not in any way equal to x squared plus 5 squared. You can't do that. This is what I've called an unforgivable mistake. And if you do this, there's absolutely no partial credit that I'm going to give you on a problem like this. If you're squaring a binomial, we know what it means to square. It means to multiply that binomial times itself. And it turns out we've got a FOIL problem. And we finish this off multiplying the first, x squared. The outside gives me plus 5x. The inside also gives me plus 5x. Product of the last, 5 times 5 is 25. Combine like terms. Now in a problem like this, wouldn't you expect for the outside and the inside to always give you the same two terms here in the middle? Every time, because the outside and the inside are going to be products of those same terms. An x times 5, a 5 times x, they both come from this having been the original problem. Well, let's look at this generically. Let's consider if I write this as a first term plus a last term quantity squared. Now if I just leave this generic and we see what happens at the end, we may discover a pattern that we can take advantage of. We know that this is a FOIL problem. Please understand that my f and my l are now referring to the first term of my binomial, the last term of my binomial. This is not the f and l from FOIL. Multiply that binomial times itself. Product of the first, f times f is f squared. The outside gives me plus fl. The inside gives me plus fl. We could write LF, but it's the same as FL. And product of the last plus L squared. Combine like terms. FL plus FL is 2FL. And we've just developed a blue box. Anytime you square a sum, anytime you square a binomial, the answer will always be the first squared plus double the first times the last and plus the last squared. Now let's go back for a minute and look at the one that we just finished working. We had x plus 5 quantity squared. This at the bottom suggests that all I have to do is take this first term and square it, x squared. Take the first times the last and double it, plus the first times the last is 5x, doubled is 10x, and plus the last term squared. Square the 5, you get 25, which is exactly what we had a moment ago going through FOIL. But now we can do it much quicker, because we have this general attack. We have this binomial that we wrote in general terms, a first term and a last term, and the answer is always going to be the first squared plus double the first times the last plus the last squared. What if this had been a subtraction? What if this had been a subtraction? A first minus a last. Let's go ahead and let's get rid of these plus signs for a minute so we're seeing exactly what we're doing. If that had been a minus, what would change in my FOIL here? Well, as I FOIL this out, f times f is f squared. Watch your signs now. On the outside, f times negative L is negative FL. The inside, negative L times F is negative FL. And product of the last, a negative L times a negative L, negative times a negative is still going to be positive. And of course, L squared. So the only difference I have is if my original binomial is a subtraction, if we're squaring a difference, then my middle term will be negative. It will be minus double the first times the last. If it's a sum, this is what we had a moment ago. And we have a positive 2FL at the bottom. If it were a subtraction, we'd have a minus 2FL at the bottom. Now she gives you this in the section in a brown box at the bottom of page 305. She gives it in two separate formulas, and she uses X's and Y's, where I've used F's and L's to remind me that's the first and the last. But this brown box at the bottom of page 305 is exactly the same as saying if I'm squaring a binomial, the result will be the first squared and either plus or minus, matching the sign of the problem, double the first times the last and plus the last squared. Now we've got to ask the question, do I really have to know this? Do I have to know this to pass this class? Do I have to know this to get a question right on a quiz or a test? And the answer is no. No, you don't. So the next question I want to ask is it a good idea to know this? Oh, yes. Most definitely. Because in Chapter 5, we're going to be doing this backwards. Chapter 5 is factoring. And factoring is unmultiplying polynomials. It's taking polynomials back apart. It's unfoiling in some cases. It's unmultiplying. And so if we see a pattern like this, we'll know how to do it backwards and get this answer. Next semester, even more importantly, you're going to be doing things called completing the square. Well, this form here at the bottom is called a perfect square trinomial. And we will use this term in Chapter 5. Not only do you need to be able to recognize a perfect square trinomial in Chapter 5, but next semester you will be given part of a polynomial and be asked to change it into a perfect square trinomial so that you can do that backwards thing that we're going to do in Chapter 5, and you can put things like the function of a parabola or the equation of a circle in a certain form that's going to help you. So, do I have to know this to be able to work the problems in section 4.6? No, you don't. You could always FOIL it out. Should I know this? Oh, yes. Learn it now, because very soon we're not only going to use this backwards, but next semester we will even be doing more with perfect square trinomials. All right. Let's repeat this rule here at the top of the board. If I square a binomial, it will be the first squared and either plus or minus, depending on the sign of the problem, double the first times the last, and always plus the last squared. So there's our rule. Now let's work some problems. And in this section, and I'll remind you again, and I'll put it on the website as well. I don't want you using FOIL. There's no point in doing this homework if you're just going to FOIL everything in this section. The point of this section is to learn these patterns and to be able to use them. Number 4 from the homework, x plus 8 quantity squared. Again, don't make the unforgivable mistake. You can't distribute that power. We know that's really a FOIL problem, but even better now, we have a rule that says if I'm squaring a binomial, my answer will be the first squared and either plus or minus, matching the sign of the problem, double the first times the last and plus the last squared. So here we go. The first squared. Square the x, you get x squared. And plus, because this will match the sign of the problem, double the first times the last. The first times the last, x times 8 is 8x. Double that, you get 16x. Does that make sense? Double 8x, you get 16x. And then always plus, and the last squared, 8 squared is 64. Done. Makes very quick work of these problems. But in addition to that, those things that we mentioned, we're going to be working these backwards in Chapter 5. We're going to be completing the square next semester on certain problems. Number 6, z minus 5, quantity squared. We're squaring a binomial, and so we have this formula. We have this pattern that says if I square a binomial, the answer will be the first squared. Z squared is z squared. And in this case, minus. This matches the sign of the problem. Double the first times the last. Z times 5 is 5z, doubled is 10z. Always plus the last squared. 5 squared is 25. Don't write just a 5 squared and leave it. That's not simplified, right? You actually need to crank that out. Get that 25 and not leave me a 5 squared. Let's crank it up just a little. Number 14. We're squaring a binomial. To square this binomial, yes, we could always FOIL it times itself, but in this section, we're practicing these special cases. And the square of a binomial is a special case. I know that my answer will be, here we go. The first squared. You square 9y. You square 9, you get 81. You square the y, you get y squared. Now, does that make sense? If you square 9y, you can distribute that power over a product. You're squaring the 9 and you're squaring the y. All right? In this case, plus, because this sign on our middle term of our answer will match the sign of the problem. And now double the first times the last. 9y times 4z, 36 yz. Doubled is 72 yz. First times the last is 36 yz. Doubled is 72 yz. And always plus the last squared. You square 4z, you square the 4 to get 16, square the z to get z squared. Boom, there's our answer. We're done. All right, let's have a look at number 18. You know I'm not going to pass up a problem like this. This is still the square of a binomial. This is the square of a sum. And so we can use our special product rule to work this problem. My answer will be the first squared. 1/4 x squared. You square 1/4. Square the top, square the bottom. 1 squared is 1. 4 squared is 16. and you square the x. X squared is, well, x squared. And in this case, plus. Now double the first times the last. Double the first times the last. The first times the last is going to be 1/4 x times 1/5. 1/4 times 1/5. Multiply the tops, multiply the bottoms, and times that x. That's the first times the last. Now double it. You double 1/20th x, you get 2/20ths x. That's twice as many, which reduces to 1/10 x. Also realize, anytime you double a fraction, you're just cutting the denominator in half, right? Anytime you double a fraction, you're just cutting that denominator in half. Every time. So, this was our first times our last, and then we doubled it. So, double the first times the last. The first times the last is 1/20th x. Doubled is 1/10th x. And always plus. And now square the last. You square a fraction by squaring the top, squaring the bottom. That even makes easy work out of a problem like this. Now look at number 20. Here in number 20, there's a point that I want to make. And that is, we never escape the order of operations. I'm grabbing the red marker because what I'm about to do is wrong. You may not even want to write this down in your notes. How about I start this problem by distributing the 4 and then squaring what I have here. The first squared, in this case plus, double the first times the last, and always plus the last squared. Now what's the problem? Well, I violated the order of operations. I multiplied 4 times this binomial, ignoring the power. Order of operations says I must deal with this power before I can consider multiplying by that 4. So the first thing I have to do is square this binomial. Then I can come back and distribute the 4 to whatever I get. So we have this 4 out front times now whatever we end up with. This is the square of a binomial, so this will be the first squared, in this case plus, double the first times the last, right? And always plus the last squared. Now that I've dealt with the power, I can deal with this multiplication out front. Now distribute the 4. And there's my final answer. So now I've got one for you to try. I want you to give number 24 a go. We'll get it written up here. I will remind you that you cannot distribute. We just talked about this. You cannot distribute that 2x until after you have dealt with this power. So the first thing you'll do is square this binomial. You'll get a trinomial. It'll look like this because it meets our pattern. And then you'll go back and distribute that 2x like the problem we just did. So go ahead and pause here and then come back and we'll compare answers. We'll start by squaring this binomial. The 2x is going to hang out. He's just floating for a minute. He's going to hang out front as we square this difference. Matches our pattern, right? So we'll have the first squared, 49x squared. And in this case, minus Double the first times the last. First times the last is 14x. Doubled is 28x. And always plus the last squared. 2 squared is 4. Now we can distribute our 2x. 2 times 49 is 98. X times x squared, product of like bases, add the exponents. X cubed minus 2 times 28, 56. X times x is x squared. And plus 2 times 4 is 8. And times that x. How'd you do? So this is one of our special cases, squaring a binomial, squaring a sum or difference. We learn this pattern. Not only can we do these problems more quickly than foiling, but we'll be ready for when we have to start using that pattern backwards, or next semester completing a perfect square trinomial. Let's consider another pattern. The product of the sum and difference of the same two terms. Both are x, both are 5. One's a sum, one's a difference. Let's FOIL this out. Product of the first, x squared. The outside, minus 5x. The inside, plus 5x. And product of the last, watch your signs, minus 25. Combine like terms. And these like terms subtract out. Minus 5 plus 5 leaves nothing. And nothing plus the rest of it is just the rest of it. I wonder, will that always happen when I have the product of a sum and difference of the same two terms? I think you can see that yes, that is exactly what's going to happen. Do you have to know the special product I'm about to develop? No. But in the next section, in the next chapter, this thing will, in the box will be the problem. You'll be asked to factor it. And so this here at the top will end up being your answer. We'll be working these backwards. That's what factoring is. It's unmultiplying. Okay, let's consider this is a pattern now. If I have a first plus a last times a first minus a last, and if I FOIL this out, I'm going to get product of the first, f times f is f squared. The outside, minus FL. The inside, plus FL. And product of the last, watch your signs, positive L times negative L is minus L squared. And just as we expected, these like terms in the middle are going to subtract out to leave me the first squared minus the last squared. And isn't that what just happened? We had an x plus 5 times an x minus 5. And the answer ended up being the first squared, x squared, always minus. Always minus. That's what this pattern says. Always minus, and the last squared, 5 squared is 25. And I didn't have to FOIL or mess with those outer and inner terms. So this is going to save me some time and also become incredibly important to know in the next chapter. Do you have to know this right now to get through 4.6 and to work problems on quizzes and tests? No. Should you learn this now? Absolutely. Because of all those reasons we have mentioned so far. Now she has another brown box for us. Tiny thing here at the bottom of page 306. The product of the sum and difference of the same two terms. I've said if we have a first plus a last times a first minus the last, that's always going to be equal to the first squared minus, always minus, the last squared. And she said the same thing, except instead of f's and l's, She's got X's and Y's. Let's work some of these. Again, without using FOIL now, we want to practice these special products. Now understand, I'm using number 28. If the problem looked like this, that doesn't fit the pattern. That's not the sum and difference of the same two terms. The A's are the same, but the numerics are not the same. These have to match. First terms have to match, last terms have to match. One's a plus, one's a minus. And it doesn't matter. This could be written as minus up front. That's the same problem. Because we know what? We know multiplication is commutative. Instead of having the guy with the plus up front, I can move him to the back. So this still meets our pattern. I'll return it to the way it originally looked in the textbook, because we are grabbing number 28. And now we work this using our special product. When I have the product of a sum and difference of the same two terms, the answer will be the first squared, a squared, always minus the last squared. 8 squared is 64. Done. That's the end of that one. Let's do another one. Number 34. Here in number 34, once again, I have the product of a sum and difference of the same two terms, and so I can use my special product rule instead of foiling this out. If I foil it out, I know that's going to work, but we're practicing these special products. My rule says that this will give me the first squared. You square 3x, you get 9x squared, always minus, and the last squared. You square 4y, you get 16y squared. Done. So easy. If I know the pattern. If I know the pattern. Especially true, look at number 42. Now, if you want to practice your FOIL with fractions, help yourself, just not in this section. In number 42, recognize that this is the product of a sum and difference of the same two terms, this plus that times this minus that. And it will always give me this squared minus that squared. That's what my pattern says. Now, if you want to stick around and do the outside, the inside, combine like terms, help yourself. This is the product of a sum and difference. That's the first squared minus the last squared, and that's how we're going to do it. The first squared, you square 7x, you get 49x squared. Always minus. You square a fraction, you square the top, you square the bottom, as we get our last squared. Square the top, square the bottom, and we're done. That was quick and easy. Let's have a look at number 44. I want to work this one two different ways for you. The first way I'm going to work it does not involve the special products from this section. I'm going to multiply this out. This is a monomial times a binomial times a binomial. And if we work this the way we did problems in the last section, we would probably distribute this p. And there's nothing wrong with that. I'm not violating the order of operations. This is all multiplication. A monomial times a binomial times a binomial. So I'm going to choose to multiply the monomial times this binomial first, and that's just distributing. That will give me 3p squared plus 7p. And now please notice this does not match our pattern at this point. 3p squared and 3p are not the same. 7p and 7 are not the same. So even if I wanted to use my special product rule, I couldn't at this point. I would have to rely on FOIL. Product of the first, 9p cubed. Product of the outside, watch your signs, minus 21p squared. Product of the inside, this one's going to be plus, 7 times 3 is 21, p times p is p squared. Product of the last, watch your signs, minus 49p. Combine like terms. These like terms subtract out, which honestly, looking at the original problem, shouldn't surprise me. And I've got my answer. And there's no problem with that because we never broke the rules of algebra. But now let's go back and work this same problem again in the light of our special product rules. If you have this in your notes, that's fine. There's nothing wrong with it. If you happen not to have written this down, because I said we're not using the rules of this section, that's fine too. But look what we have. We have 2 binomials in our second step. We have 4 terms in our third step. We had to combine like terms to get down to our answer. So keep in mind what this looks like, and let's compare it to working the problem using our special product rule. Instead of dealing with the p first, I know that multiplication is associative. That is, I can group these however I want. Instead of multiplying the first polynomial times the second one, I see right here the product of a sum and difference. So that's where I'm going to start. I'm going to start by multiplying these 2 binomials together and noticing that it fits my pattern. The product of a sum and difference should be pretty easy. This p is going to float for a minute while he waits on me to get done. Product of a sum and difference is going to be the first squared, always minus the last squared. 7 squared is 49. Now the only thing left to do is distribute that p. Of course I got the same answer. I never broke the rules. But man, I got that answer a lot faster this time. So there is benefit to it. I demonstrated to you that you don't have to use these special product rules to get through the problems in this section. You can FOIL. But I've also indicated to you many reasons that I want you to learn this section. It's either learn it now or learn it later. And it's going to be tougher to learn it later because later we're going to assume, I will this semester, your instructor will next semester, we're going to assume that you already know these special products. Let's finish this section with a couple of geometry problems. Number 78. In number 78, we're given a figure that upon inspection is clearly a square. She's even marked a 90-degree angle in the corner. And the length and width are the same, so we know it's a square. We have been asked to find a polynomial that represents the area of each figure. So my instructions, you've seen them before, would simply say find the area of this square. Well, the area of a square is a side squared. And like we've said before, that's just length times width, where length and width are the same and we call it a side. Plugging in, we have a binomial squared. And we know a very quick and easy way to take care of that now. I know that when I square this, I can either FOIL it times itself or use my special product rule. The square of a sum is going to be the first squared, 36p squared. In this case, plus. Double the first times the last. Double the first times the last. The first times the last is 6pq. Doubled is 12pq. And always plus the last squared, q squared. Find the area of this square, done. Let's look at number 80. In number 80, we're given a triangle whose base measures 4b plus 1 and whose height measures 4b minus 1. We're asked to find this area. The area of a triangle is 1/2 its base times its height. In this case, that'll be 1/2 times the base, 4b plus 1, times the height, 4b minus 1. And in this section, I want you practicing the special product rules. So I don't want you using FOIL in this section. Recognize this special product, the product of a sum and difference of the same two terms. So let's knock that out. This 1/2 can just float into the next step. He's hanging out, waiting to see what's going to happen. And the product of a sum and difference is just the first squared, always minus the last squared. 1 squared is 1. This is a good example of why your 6's and your little b's should not look too similar to each other, right? As we continue to develop our technical handwriting. And then to finish this off, distribute the 1/2. Half of 16b squared is 8b squared. Minus 1/2 times 1 is just 1/2. Done. Easy enough. Again, in this section, let's not use FOIL. Although FOIL could be used in every one of these problems to work them. And if you're in doubt on a quiz or a test and you go, am I remembering my special product correctly? If you feel more comfortable with FOIL on a quiz or a test, go with it. But there are many, many reasons that you want to get these two special cases down pat before we enter the next chapter and before you go on in math in the next semester. So that's it on this section. I'll let you get to that homework.